Hi, everyone. Thank you for joining me. My name is Anthony. I'm a dev rel at Flare. And today we're going to be doing a deep dive on FTSO's custom feeds. We're going to cover how you can securely and in a decentralized manner bring on time series, arbitrary time series data onto Flare. And just setting the expectations here, here's a quick look at our agenda. We're going to uh, first talk about briefly what Flare is, and I'm not going to spend too much time on that because we have plenty of other videos in this Academy series that talk about that and talk about the two enshrined oracles that we have that are going to make building the custom feed that we're going to show today uh, 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 using FTSO and FTC. And then the main event will be actually creating these custom feeds where we're going to go through a live coding walkthrough, um, showing you how to leverage FTSO and FTC to do that. And then as a bonus, if we have some time, which I think we do, we think we will, I'm going to show a few adapters that I created. So if you're used to using an Oracle on a different network, uh, the adapters simply are going to uh, use that same exact interface, but are going to be using and caching FTSO data using the FTSO v2 interface behind the scenes to make it easier to migrate to Flare, which is already easy to do because it's its own layer one EVM chain. And at the end, we will have some Q&A, so make sure you have some questions for me at the end, and we may have a little surprise as well for you to potentially win some merch. So if you're familiar with the Academy series, you may have seen this slide many times before, and if you're not, I encourage you to go back and uh, look at those videos. Uh, but it tends to start with this slide, which is an important reminder because it's a core concept of blockchains. So blockchains are designed to be secure. Uh, they're deterministic fortresses, and every node can independently verify the entire chain, which gives us this incredible amount of security and censorship resistance. And we have the security, but it also gives us a limitation, which creates an isolated environment, right? Blockchains are isolated environments. They cannot natively access data from the outside world. So the critical question you have to ask yourself as a dApp developer is how do I get external data onto uh, my smart contract? How do I know the price of Bitcoin, for example? How do I know the score of a game, maybe to settle a prediction market? Or what's the weather in London? Okay, these are questions that Flare is answering today in a decentralized, secure way. Um, and getting this data, it's a classic Oracle problem. So if your Oracle is insecure, your dApp is built on a foundation of sand, really, regardless of how secure the L1 is. Something that I like to say is that your smart contract or your dApp is only as secure as the weakest link in your application. So you could be building on a very secure network like Ethereum, for example, battle tested network. But if you're using an Oracle where the security guarantees are opaque, you're going to have run into some issues over the long term um, with that. So on Flare, how are we securing these oracles? Most blockchains solve the oracle uh, problem with external third-party providers, and these services have their own often opaque security models and are sometimes secured by a very small number of nodes. As few as I believe five for some price feeds. And Flare's approach is fundamentally different. Okay, we're enshrining the oracles directly into the protocol, and this means that the same uh, people who secure the chain, which are the validators, we give them this added responsibility of acting as a data provider. Um, and that means that your data is secured by the entire stake of the network with up to 100 data providers. Uh, contributing to every single feed. And it's also a permissionless system that anyone can join. Uh, but that creates a clear, quantifiable security model. And the security of your data is the security of the layer one itself. Okay. Now, one of our enshrined oracles are FTSO. Uh, this is for probabilistic data, and you know, basically what probabilistic means are things like weather data, uh, where it's okay to have a smaller discrepancy. Like if you're getting the price of Bitcoin at 114,023 cents, it's okay to use 114,074 cents. And FTSO is available every block. We have block latency updates, updating every 1 to 2 seconds. Uh, and it's completely free for dApps to read on chain. And they're anchored to the scaling price, which is a full median calculation of the price from all the data providers every 90 seconds. And data providers are incentivized economically to get closer to that price. Um, so it's a real-time price infrastructure into the network. And briefly, FTC is our second enshrined oracle. It's used to bring in deterministic data on chain. So things that are provably true or false. Uh, you're getting a yes or no answer. So, for example, did a specific Bitcoin transaction happen? What was the score of the World Cup? Uh, and most importantly for us, when we talk about custom feeds, which is the next slide, what was the what was the response from a specific Web2 API endpoint? Okay, and FTC is pull based, so you're making a request, like you would make a request to an API. The entire validator set um, comes to a consensus on the answer and makes a cryptographic proof available on chain. Now to custom feeds. So we have FTSO for standard price feeds and FTC for um, bringing in any other uh, data. Uh, we're using. I'll show how to use both of them to create a custom feed. You don't have to strictly use both of them to create a custom feed. I think it would be interesting to demonstrate how we're using both of these enshrined oracles to create a custom feed. And I'll show you a fully on-chain version of a custom feed, which is a staked flare, uh, uh, which we'll get to in more detail a bit later. So custom feeds were introduced in the Flare improvement proposal in, I believe, February 23 of this year. Uh, and it's a custom feed that you, the developer, create. Okay, that means that the risk is the developer logic, whoever is building the smart contract. You're defining the data source and you're defining the on-chain logic. So your contract, um, which will show, can use FTC to fetch or verify data from off-chain APIs, and then exposing that um, on chain using the same interface as the other FTSO uh, feeds, which I can show briefly a bit later. Although we do have other videos covering FTSO in more detail. So this means that you can create a price feed for virtually anything, a liquid stake token, a specific stock, uh, or the inflation data from the World Bank, or data from economic data from uh, Fred. We have a Federal Reserve meeting today, actually, and metal prices that we'll be looking at today. Uh, so creating a custom feed, this is a very high level overview before we go into any code. Uh, we're basically going to be extending this uh, interface for custom feeds, which standardizes the implementation of building one. A very simple interface. I think there's only three functions um, that you're extending. Uh, we'll have this on-chain logic, which we're which I which will do what I just mentioned. Then we'll have this off-chain logic, which is going to be querying the API and running through the Flare data connector flow. Um, and the management or governance of custom feeds also comes to um, you after you create the custom feed, you have to request or submit a request on the GitHub, um, which I'll show you to get this accepted by all the data providers. And last, I think one more slide. Yeah. So these are the examples that we're going to be showing in more detail. Uh, we'll have the off-chain and uh, on-chain component of CoinGecko. Will show how to you can get a Bitcoin price, verify it, and put it on chain. Same thing with the gold price, inflation data from the World Bank, and we'll show you one of the first custom feeds, which is staked Flare, which is fully on chain and just performs a calculation. Um, and yeah, let's go through a walkthrough. This is the uh, hard hat starter that we have. If you just uh, Google this, uh, yeah, if you just Google the hard hat starter Flare Foundation, you can find it, and then go to the custom feed folder. So I will now stop sharing this, turn my camera off for a second so I don't lag, and show some code. Okay, so we have, let me, give me 1 second, folks. Bear with me 1 second. Okay, so you should all be seeing my screen right now, where we defined a smart contract for getting that CoinGecko Bitcoin price. This is the on-chain component. As you can see, we are bringing in the custom feed interface, extending the contract with it. And if you scroll down, this is the one of the main functions of custom feed, which is getting the current feed, which we're going to be supplying. And I'll go into greater detail in the smart contract after I show the off-chain component with FTC. We have the uh, logic for the FTC pretty much abstracted now. Uh, we've gotten to a point where we've condensed a lot of the logic into all these helper functions, so you don't really even have to think about it. But with FTC, you know, this is where a lot of the action is going to be happening. So we define our API URL, which is where we want to pull some data from. As you can see here, this is our API URL from CoinGecko, um, and we send a request to a verifier server, which is going to uh, give us the standardized format for the request um, for FTC. Uh, and I'll show this when I actually run the script uh, and show you what the hex encoded um, request will look like. And the second thing is once we get that back from the verifier server, we can then take this request and submit it to the FTC Hub contract. And this is a simple on-chain transaction that kicks off the process of verifying it on chain. And then you want to wait and receive the proof uh, to make sure that you can actually use this data. Once you run the script and uh, get the data and verify it on chain, then you can actually use that data. Okay. And then we'll walk through some other logic here. But this is the main flow to make it easier to understand through code. So we're preparing the request, submitting it, retrieving the proof from off chain of the DA layer, deploying it, and then interacting with the contract. And this is where we're submitting the proof. Um, and I'll show exactly how this works. Let me just comment out the verification of the contract. So it's a bit faster. Or no hard hats. Run price verification script. So right now we're going to prepare the attestation request. So this is what we're going to send to the verifier server. This is what the ABI encoded request looks like, just hexing all of that information. It looks pretty ugly, uh, but simple once you understand the flow of FTC, which can take some time. Uh, we have plenty of information on our developer hub that developers can go through to understand step by step what's happening in FTC. Basically, we're getting information from the external world, verifying it before we use it on chain, and then we can use that data on chain. And now we're waiting for the uh, voting round to finalize um, on the network. So we're sending this request to the data providers, and they're submitting that request on our behalf to the API, and then coming to consensus on that data. This will take a few seconds. My network might be a little slow because I'm sharing, but that's okay. Now let's check the round progress. See how this is progressing. And let me not do that actually. So it seems my network is running a little slow, which is okay. Okay, so that's the prepared request. The round finalized. Now it's going to continue to pull the DA layer to get the proof. But this is the main idea here that we're doing with FTC. We're we first we want to figure out what data we want to bring on chain, which is the Bitcoin price that we're bringing on. And a lot of this logic here, uh, you can kind of disregard. It's just preparing the URL that we're using. Then we have a post processing, which is if you look at the response you're getting back from an API, we're formatting that response correctly to get the information that we want. So in this case, it's only the price data that we're getting. Uh, and then we get the ABI signature, which is where we're um, storing the price that we're getting, uh, or the data that we're getting from the API, um, and some parameters for the API URL. Uh, and we're using FTC. You have to define the attestation type, the source ID, and the endpoint that we're going to be using for the verifier, which is just helping us prepare requests, and then running through all the logic that I've been talking about. Something to point out, though, is if maybe you're not familiar with FTSO, but everything, all the feed IDs are um, these hexadecimals, and they're grouped by the category that they're in. So the 21 group, if you see feeds that start with 0x21, that's an indication of a custom feed from the specification that was approved. And then it's the hexadecimal of the feed name, which you can see is being defined here. The price symbol is BTC, and it's a historical price we're getting from CoinGecko. This is going to be required when you're creating a custom feed. If we go back to the smart contract, while this is running, we're passing in the feed ID when we deploy the contract and the expected symbol. And then the constructor will run and initialize all this information. And something to point out here, the most important uh, function on the smart contract is going to be verifying the price. And to do that, you need to verify the proof that we're getting. And which a script is currently doing for us. So when you pass in the proof, we're going to do a few things. So whenever you write a smart contract, you want to ensure that no one can manipulate the code. And the way that we're doing this is we're extracting the API URL. Uh, we're getting the uh, calling it a coin ID, and then doing some require statements to ensure that no one can mess with that. Uh, we're passing the URL to this extract CoinGecko ID from URL function, which if you scroll down is doing all of this logic to ensure that this is a URL that we want to begin with. Okay, then after that passes, we're decoding the price data. So we're taking it from the large proof that we're getting back from FTC, and then setting it as a state variable and then emitting that information. Like I mentioned, for the custom feed logic, one of the most important points is the um, getting the current feed function. And it looks like I'm having some network problems running this, so I will go ahead and show you manually uh, the interface for custom feeds, which is pretty simple. This is not the right tab I want to show you. So this is the custom feed. Um, one second. This is the custom feed interface that we're importing from the Flare periphery library. It has three functions: the feed ID, which needs to be structured with 0x21 to begin with, getting the current feed, and calculating the fee. And this is what each smart contract for a custom feed must implement. It makes uh, implementing the uh, custom feed a bit easier. And one of the first custom feeds I wanted to show earlier was the staked uh, flare that is fully on chain, um, which I have right in front of me. And if you go to our Dev Hub, open up the Flare improvement proposal, this is where you can read about the actual proposal that was accepted. And if you go to the SFLR custom feed, this is how this fully on-chain custom feed was implemented. So this is not using FTC. It's pulling in another uh, contract to get the value, and while it's doing that value, you can read the contract for yourself. Is doing some uh, modulation to get the value, storing that, and then making it available through this get current feed function. And it's pretty simple to implement. Okay, so I'll stop sharing that for 1 second just to check that nothing crashed on me. Maybe I have to refresh. Okay, maybe someone can comment that they can hear me again. I went out for 1 second and had to join. I think my restream crashed. Fennel Bass, can you see me? Made a comment. Can you hear? Okay, great. Thank you, Brandon. I appreciate that. Okay, so that was a bit fragmented because my network kind of went down there. Uh, but those are the main points of the custom feed. So we're using this. We're using both oracles here, FTC to get off-chain data, verify it, use it on-chain, and then the custom feed interface. We're implementing that on-chain and exposing it the same way that we're doing for. We're using the same interface that we're doing for FTSO. Uh, and that's the main logic behind custom feeds. The only caveat, I believe I mentioned this, is that you have to get it approved by the Flare management group, which you can do on chain, or sorry, not on chain, on GitHub rather, not on chain. Uh, and these are the resources that will be available after this is posted that you can go through. I suggest going through a dev hub, which will go through all the steps for CoinGecko, uh, our hard hat starter, the Flare improvement proposal. You can look at the interface for the custom feed, and uh, the bonus that I mentioned before for the adapters, uh, which I can show very briefly. Hopefully, my network doesn't uh, crash again. So if you're used to building on Chainlink, Python, or another uh, Oracle system, I created these very simple adapters that are simply taking those interfaces. For example, if you're from Chainlink, you're probably used to using the latest round data. All that's going to be doing for this library is that we're calling this refresh function, which is going to call the FTSO v2 interface for the specific feed ID that you want. and you can use that, in your off-chain logic as well. I just call the refresh function there. That's a little bonus for all of you interested to look at. Now I'm seeing a blank screen again. Okay, looks like that crashed again. So I will move to question and answer now to avoid any crashes from happening again, unfortunately. So maybe if anyone has a question, you can write it in the chat. I can see some of you already uh, writing in the chat. And let me bring up the presentation again for people who have stayed towards the end. Here's some QR codes, which are DevHub, Twitter, Discord, uh, and you can scan this here for a chance to win some Flare merchandise. We just released our Flare merchandise store actually, uh, so you can take a quiz, and if you get all the questions right, we can send you some merch. Are there any other questions? Give you some time to scan the code here. So coveted crypto said, I own some Flare, but have no clue what it actually does. We can delegate Flare. You can wrap it. You can, you know, you can use it to secure the entire network of um, the entire Flare network. It's a simple answer. Okay, Habzolov said, I'm in now. I'll watch it back. Thanks. Yes, this is going to be made available on what's my X handle. So this is going to be made available on YouTube and wherever this is restreamed. It should be on our DevHub page as well if you want to watch it back. My X handle is 0x reflexivity. I don't post much, which I should probably start posting more. So it will be used cross-chain or just on XRP ledger. So the native token, the value of it should accrue to the native network. This is why layer twos, in my view, wouldn't work. Um, but because we have a secure network, we and that value is going towards our oracles, uh, we can uh, use our native oracles to do cross chain. Um, look at off-chain uh, data and do off cross-chain uh, interactions. So, for example, if you spend some time looking at FTC, the way it works is that we have these predefined attestation types. I showed you today the Web2 attestation type, but most of them, about four of them, they're used to see if we're used to see if another blockchain is progressing, like XRP, for example, what the current block height is, etc., to see if it hasn't stopped. And we're using that information to create F assets, for example, which is a two-way collateralized um, bridge. So you can bring in XRP and mint FXRP on the Flare network. You still have plenty of time. You can ask whatever question you like. Ideally, make it about Flare. What would be a smart plan of action after the Flare drops? And so the Flare drops are ending soon. Uh, I would hodl if I were you. It really depends on what you want to do with um, on Flare. There's a lot of interesting things coming on Flare. Working with some very interesting groups. Brandon swearing in, hodl is the mission, and this is not financial advice, by the way. Are there any questions about custom feeds? How FTSO is working? I kind of skimmed over the two oracles um, because we have some other videos covering that in more detail. So I can certainly answer any other questions about those oracles. Okay, so Flare Networks has asked me a question. What would be a good use for a custom FTSO feed? Well, I think one of the we have staked Flare for a custom feed that I don't believe is live yet. Uh, that's a good custom feed. Uh, the idea is to bring in arbitrary probabilistic data. So it could be, an equity price, for example. It could be treasuries. It could be, well, if you take treasuries, you can build other applications around that, decentralized applications using that data that you're bringing on chain. And the way it would work, I don't think I mentioned this, but the way that it would work for using the off-chain and on-chain component, you would deploy the off-chain component and have it run, every block time, or really depending on the API that you're using, if it has high availability or not. And that'll run, let's say every block time. So each time it'll run, really can only run only 90 seconds, because that's a minimum that it can run, because that's the time it takes for FTC to run. So that'll be running off chain every 90 seconds, uh, updating the on-chain custom feed smart contract that I showed you that you can create. Are there any other questions from the audience? Do you, Female Bass, you're asking me, do you use AI to help you code? Uh, Sometimes yes, sometimes no. I think it's good to tab, but to one shot a lot of this, especially in blockchain, probably isn't a good idea, because you want to ensure that you're writing good code. So, well, especially for smart contracts is what I'm talking about. But okay, thank you everyone for joining. This was a presentation on FTSO Custom Feeds, part of our Academy series that Flare runs. Thank you for joining. I do want to invite all of you, good people watching, to another X Space that is happening uh, for community growth uh, grant recipients. They've worked really hard. Uh, Great people. You should come and see what that's all about. And that will be on the X link that was just shared with you all. Uh, Click on that, and that should be live uh, 2 p.m. UTC for everyone to join. And I will see you there.